Okay, this is the Math 140 video lesson 3, quadratic cost, revenue, and profit functions. Let's suppose that a company has a fixed cost of $500 per day and a variable cost given by x squared plus 15x, where x is the number of products that are produced and sold. So the more they produce and sell, the higher this variable cost. Further, suppose that the revenue function is R of x equal to x times P, where P is the price in dollars per unit for the product and is given by the equation P equals 100 minus x. You can see in this equation that higher levels of production and sales correspond to lower values for the price. Sketch the cost and revenue functions individually but together on the same graph. Use Desmos.com to produce the graph. You don't really have to use Desmos.com. This is a nice, easy website to produce some very professional looking graphs. You could use other things, but this one is very easy to work with, very interactive. So I'm going to use Desmos. On Desmos, use the gear icon in the right-hand corner to adjust the window, find an appropriate window to view the relevant portion of the graph, and that is particularly to restrict the graph to the interval where you've got x greater than or equal to 0, because x represents how many units of some product are produced and sold, and so it wouldn't make sense to have a negative number of units. Okay, and then print the graph, locate and label the regions of profit and loss in the graph. Show the algebra that's required to find the break-even points, specifically using the quadratic formula to determine and label those points in an accurate graph, and show that work and attach that work. And use the computer to label the break-even points and label the axes, or you can write them in with pencil after you print it. Reminder, restrict the graph of the revenue and cost functions to include only the interval for x greater than or equal to 0. All right, so if we're going to graph these two functions, let's make sure that we're clear on what we're going to graph. So I'll just sum it up here and say I've got two functions that I want to graph. The first one is the cost function. The cost function is made up of both our fixed and variable costs. The cost as a function of the number of items produced is the fixed cost, and the variable cost, let's write it x squared plus 15x. That's the variable cost. The number produced, the more is produced, the higher these variable costs. Materials, labor, things like that are variable costs. There's a fixed cost that you can add on to that, given as 500. So that doesn't change, doesn't matter how many is produced, there's always a fixed cost of 500. So that's the total cost, and the revenue, that's also given. Revenue is given as a function of the production level and the sales level. The revenue is x times the price. That's clear because whatever your production and sales level is, if that x could also be called your demand level. So whatever the level of demand is, that's how many you sell, and this is the price you're selling per unit. So if you sold 100 units at $5 each, it'd be $500 in revenue. Well, in this case, the price depends on the sales level, and the price is 100 minus x. So if you sold 50 units, they're actually selling at a rate of $50 per unit. If you were selling 10 units, they'd be selling at $90 a unit at that level. Okay, so this is the revenue function, and the purpose here was to first thing is to graph each of these functions individually and together individually on one graph. So let's go to Desmos and take a look at what I mean by that. Okay, so the two functions that I had were the revenue, which was x and 100 minus x. you could multiply it out, 100x minus x squared, or just leave it factored like that. It doesn't matter. It's going to produce the same graph. But I know that negative x's aren't relevant in this case. So let's do the same thing we did before where we'll put a restriction x greater than. I just type the greater than sign and then I type equal right after it and it creates the greater than or equal. And so I put greater than or equal to 0 so that it only graphs values where x is greater than or equal to 0. Okay. I'm not going to adjust the window yet. Let me put the other one on there. The cost function was x to the power 2 plus 15x plus 500. And let me just make sure. X squared plus 15x plus 500. And I want to put the restriction that x is greater than or equal to 0 on this one also. And yeah, we really can't see anything in the picture as it is. So this would be a reason why you would do the algebra first, to figure out what is an appropriate window. I mean, you could zoom out, but it's not totally obvious really what we're looking for here. And so it actually helps. You might be able to figure it out now with this, but point is that you can do some of the algebra to get exact values, and that could lead you to a better graph. I mean, if you were graphing this by hand, you could use those 2 points to build a better graph by hand than if you didn't have them. So yeah, what I'm gonna do is I'm gonna find the points where these curves cross, and those are the break-even points, and that will help me pick a good window in which to look at. So let's come back to that. So it says use to get an appropriate window. Well, part of finding an appropriate window would include the break-even point. So that's break-even, of course, is when when the profit is 0, which is equivalent to when the revenue and cost equal. Break-even. So I'm going to find the solution to this equation um, as the two break-even points, and then use that to improve the graph because I'll have a better sense of the window that I need. Well, solving this is a quadratic. It doesn't really matter which side you put the two terms on. Why don't we go this way and say if you add x squared on both sides, and I'm sorry, that was a 100x. I need to multiply the x in. So when I minus 100x from both sides, I get an equation that looks like this. Let's use the quadratic formula. We've got a equal 2, b equal negative 85, c equal 500. Put in the quadratic formula. So by the quadratic formula, we've got negative of negative 85 plus or minus the square root of the b value squared, 4 times the a times the c. Then I have 2 times the a. And let's simplify this. We have 85 plus or minus square root. Now we got to do negative 85 squared. That's 7225. And then it's a minus here. So minus, it's actually 8 times 500. That's 4,000. Everything divided by 4. So that's going to be 3,225 divided by 4. Now to combine these, I need to get a square root of 3225. Probably doesn't come out to be a whole number, so let's use the calculator here. 3225 square root's about 56.8. Didn't say in the directions precisely how accurate you have to be, so it seems in this context, 1 decimal is okay. That's all divided by 4. And so now that we're ready to add the two together, we'll have to add it once with a plus and add it once with a negative. So the whole calculation once with a plus, the whole calculation with a minus. So I get about 35.45. Now you might get slightly different value here because you might have rounded slightly different somewhere in this irrational value. So you don't have to have exactly the same value as somebody else. You can go to really any level of accuracy here. Let's say one or two places is appropriate in this context. And so I'll have 35.45, and then the other one about 7.05, and that's just rounding to two places. So there are two break-even points. It's possible that one of these guys could be negative, and then it wouldn't be a solution in the context of production levels. You could have a negative solution that you just discard. It was a solution algebraically to the mathematical model, but it doesn't have any practical meaning in the context. If one of those were negative, you just drop it. So this is both of them positive in this case. So break-even points are x equals 7.05 and 35.45. Now, that's the number of units produced and sold. So we might even just round that off to 7 units and 35 units. Or maybe X could, in another situation, represent how many 100 units. And so it might have been around 705 units that were as a break-even point, or even like 7 million 50 50,000, or so the decimal could be significant if X represented hundreds or thousands of units produced. But that's the values that I get in this situation, and so now that can have some implication in trying to set a good window in order to see. So we go back to see what's significant here. So let's go back to the graph, and I now know that break-even points occur at 7 and 35. In fact, another thing that maybe I could have thought about is just the fact that the revenue hits zero when you sell 100 units. So that's also kind of a significant boundary for the window. So I think even though 35 is significant as a break-even point, there's another value of 100 that's also kind of important. So I'm going to set the window to go up to 100 on the X scale. Now, another thing that's maybe sort of important here is that what happens if you produce like some. Well, let's see what happens if we just create. So I need to think about the horizontal scale and the vertical scale. Let's start with the horizontal scale. So if I go now, we could start at 0 and go to like 100, or maybe you might start at -10 just because it makes the picture look good when you can see the vertical scale. So I'm going to go to 100. Yeah, it already sort of takes care of finding an appropriate vertical scale. Like I didn't have to figure that out. I could have, realizing that this is a parabola, sort of figure out what's a maximum value for that, the vertex, and included that as if I was trying to sketch it by hand. But here on the computer, it kind of did that automatically for me. So I see the vertical scale going up to 2500. So that's pretty good. And then let's just zoom out a little bit. I like when it's clear in the picture that you can see these scales, and it doesn't happen if I start them at 0. I do want to start the graph at x equals 0, but then let's say the curve at x equals 0, but then the graph itself, I might go a little bit beyond that so that we can actually see the axes clearly, right? So this one's starting at -500 on the vertical scale, and it's starting at -20 or maybe -25 or something on the horizontal scale, just so that we can actually create a little bit of space here and a little gap so that we can clearly see the axes. In fact, that was one of the things that we could do here with the computer, is to include labels for the axes and the break-even points. So let's do that. So let's first of all label for the x-axis, that is both production and sales. of course, in a real life situation, you might produce a lot more than you can sell, or you know, well, your sales and production may not be the same, but we are looking at some other ideas right now besides that. So we simplify the uh, situation to assume production and sales are the same in sort of this sort of idealized, perfectly efficient market. Um, so that's production and sales together. And the vertical scale, that was just dollars. It was both a picture of the revenue curve and the cost curve. Revenue curve goes up and then back down. The cost curve just increases. So this is just dollars for both um, revenue and cost. And the break-even points are here and here. So let's see if I can get this thing to label. Um, Maybe I'll just use a point. So um, the point 7.05, and then, well, here's where I kind of need to know what happens when you plug in 7.05 into both of these. It should produce the same thing. Actually, it wouldn't produce exactly the same thing, but yeah, I'm not sure on Desmos. So maybe what I need is just on the calculator. It's easy enough. Let's do it on the calculator. So I noticed that in the graph that I pulled up, it looks like I have some data from a previous graph and I want to get that out of there. So let's go back to the stat plot and you could just turn that off um, right there. And that'll work. Um, it's also a situation that sometimes comes up. If I hit the stat button and I cleared that out, so let's go into the data that I had typed in before. If I go to the very top, hit clear, that wipes out that column. And if I go to the other column, go to the very top of the column and hit clear, I cleared out those data points. But if I still had my stat plot set as on and I cleared out the data, then you'll get an error from the calculator. It'll say like invalid dimension. It really doesn't like that when you're telling it to plot data and it doesn't have data to plot. It gets really upset. So um, if you're going to keep the plot one on, then you got to have data in there. Um, you can just turn it off, or if you clear out the data, you got to turn the stat plot off. All right, so that's taken care of. Let's go back to the Y editor. What I want to do is type in both my revenue and cost functions. My cost function was x to the power 2 plus 15x plus 500. I'm doing this because it's easy and quick to get values for the revenue or for the cost. I might as well do the revenue while I'm at it. So the revenue was x and then 100 minus x. And now I can just use the table. So second table, and because I have it on ask, or let me see if I have it on ask. So table set is right here. The second table set, it's on ask. That's good. So that way I can type in whatever value I want. So if I go back to the table and type in something like 7.05, then I can figure out what the cost and revenue is. It doesn't come out exactly the same because 7.05 wasn't exactly the break-even point. Um, it was more like 7.053. So if I typed in 7.053, I think that's a little more accurate. So I'm getting closer. So it's about 7.05 and about 655 in revenue and cost. So that's just something I wanted to include in the graph. And the other break-even point was like 35, 35.45, I guess is what I came up with. And let's see, 35.45. Yep. Again, it wasn't exactly 35.45, and I can see that because I'm a little bit off with my revenue and cost not being exactly the same, but I know that's happening only because I know it wasn't exactly 35.45. This is fine. Let's just leave it at that. So we're going to put in 1 point at 7.05 and like 6. Yeah, you can go 655, you can go 656. It's in the context of this particular problem, those distinctions aren't really important. So let's say we'll go 656, so 7.05 and then 656. And you see it doesn't even really matter. It's that point. And yeah, I want to label that as a break-even point. And I got another one at 35.45, and what was it? 28, 2288, 20, 2288.5 maybe, something like that. And yep, that's another break-even point. And then I think I'll rather do this either printing it out and writing in with pencil, or um, overlapping with a computer program like a PDF editor, where it's in this region where you've got the revenue higher than the cost, and therefore you're making profit. The profit is made in this interval between these two break-even points. Outside of those break-even points, if you go above 35, then your cost is more than your revenue. And if you're less than 7, um, your revenue is less than the cost. The cost is higher. So in both of those cases, you'd be losing money. Only between the break-even points is there a positive profit. Yeah, so I think that pretty much wraps it up for that. One thing I could do is I could do on a PC, you can do the snipping tool. On a Mac, you could just do a screen capture. So I'm going to do the snipping tool because I want to capture this region, and then you could just paste it into a Word. So you don't even really necessarily have to print it. You could just have it go right into just paste it right into Word. And then in Word, I could use Word to create labeling the region of profit. That was part of the directions. It says locate and label regions of profit and loss. When you're in Word, you can save your document from there. If you put something into Word, you can save it as a PDF from Word, and then you could submit that PDF that way. And that's here I could possibly add in some annotations to indicate the regions of profit and loss. Well, finally, it just had to write it in with pencil. The computer that I'm using to record doesn't have the ability to edit the PDF. So I just decided to print it out, write it with pencil, and I included this little note that says profit for production and sales levels between 7.05 and 35.45. If we're in that interval between 7 and about 35, we see profits because revenue is greater than the cost. I would like to add in a C for this curve, have a C and an R for this curve in the graph. But I'd say it's clear enough. It's here. It's labeled with the colors, and we identify what these curves shape look like. So I think that's sufficient since these are included on the side. But it'd be nice to actually write it in with pencil as well. Anyway, so uh, production and sales between about 7 and 35 results in profit when your revenue is higher than your cost, and losses are in this interval that's between 0 and 7.5, and any production level over 35, again, losses. All right, so that's really the end of that one. Hope that was helpful.